Yes, students, the one of the important concept that we are discussing in what cross product is the perpendicular distance from the point C from a what straight line R bar is equal to A bar plus TB bar. R bar is equal to A bar plus TB bar, which represents a line passing through the point A bar and parallel to the vector what? B bar. Students, let us apply the what? Definition of cross or vector product of two vectors to the what? Finding the perpendicular distance from the point C of C bar to the line R bar is equal to A bar plus TB bar. Since R bar is equal to A bar plus TB bar represents vector equation of a line passing through the point A bar and parallel to the vector B bar. Now what is that? The perpendicular distance from the point C of C bar from the line R bar is equal to A bar plus SB bar, where S belongs to R, is dash. It's a theory oriented concept. Let us see. This is a point C of C bar. This is a line passing through the point A bar. It's a general point. This is the vector parallel to this line. From this point I am supposed to find out. This is AC bar. This is the perpendicular distance. You take this as H. Right? If you want, you can construct a triangle. Okay. Now what I do is, the proof of this one is, let OA bar is equal to A bar, OP bar is equal to R bar, OC bar is equal to C bar be the position vectors of capital A, comma P and C respectively. B bar is the vector parallel to the line AP bar. Now, from figure, what I can write is, H is the what? Perpendicular distance. It's in a height. So therefore, this is the vector parallel to this line. From figure, area of triangle, I can write as half into height into modulus of height into B bar. It's a B bar. Okay, another one is equal to, this is one way. The other way is, by using the definition of cross product, I can also write AC bar cross B bar. This acts as a base. Why you are taking B bar? Because it's a parallel to this line. So therefore, vector may be anywhere. If it is parallel to that, that can be taken as a parallel vector. So therefore, I can write this and this goes. I can write H into modulus of B bar is equal to, the vector AC bar is not given. I can write OC minus OA cross B bar. OC minus OA cross B bar. So therefore, H is equal to, this is C bar minus A bar cross B bar whole divided by modulus of B bar. This is called the perpendicular distance from the point C of C bar to the line passing through the point A bar and parallel to the vector B bar is given by modulus of C bar minus A bar cross B bar by modulus of B bar. This represents the perpendicular distance from the point C of C bar. Let us recall this concept for giving one example as a desired. Now let us see what I take is, now if I take this point as, yes, come on, 1, 2, 3, I'll go for this an example. The perpendicular distance from C of 1, 2, 3, I plus 2j plus 3k to the line R bar is equal to I plus j plus s into 2i plus j minus k. I have taken some vectors. Don't worry about the answer, but only thing is concept has to be verified. Now according to this one is, the solution of this one is C bar is equal to is 1, 2, 3 and A bar is equal to I plus j is nothing but 1, 1, 0 and B bar is equal to 2, 1, minus 1. Just you find out C bar, minus A bar, C bar minus A bar. C bar minus A bar, 1 minus 1, 0, 2 minus 1, 1, 3 minus 0, 3. I got it, C bar minus A bar. Then you find out C bar minus A bar cross B bar is equal to det. It's a I, it's a J, it's a K, I, J, K. Then if I take C bar minus A bar as first, 0, 1, 3. What is B bar? 2, 1, minus 1. Come on, expand it. This gives as, you can take here, you can take this one as I into, yes, 1 minus 1, minus 3, minus j into 0 into this, minus 6, plus k into, yes, 0 minus 2. This is nothing but C bar minus A bar cross B bar is nothing but minus 4i plus 6j minus 2k. Then modulus of this one is modulus of C bar minus A bar cross B bar is nothing but 16 plus 36 plus 4. 36 plus 4, it's about 40. It's a root 56. And modulus of B bar. What's the modulus of B bar? Modulus of B bar is equal to root 6. So therefore, the perpendicular distance D, perpendicular distance is equal to modulus of C bar minus A bar cross B bar by modulus of B bar is nothing but root 56 by what? Root 6. This gives the perpendicular distance from the point C of C bar to the line passing through the point A bar and parallel to the vector B bar is given by modulus of C bar minus A bar cross B bar by modulus of B bar. Let us find out the equation of a straight line passing through the point A bar and perpendicular to B bar and C bar. So that is in terms of R bar, A bar, B bar, C bar is given by R bar is equal to A bar plus S into B bar cross C bar. Let us see. If I take this as a plane, this is a plane passing through the point A of A bar, P of R bar. This is the vector. Now there are two vectors, B bar and C bar are perpendicular to it. The vector equation of a straight line passing through the point A of A bar and perpendicular to the vectors B bar and C bar is R bar is equal to A bar plus S into B bar cross C bar. This is the plane passing through the point A of A bar. When one point is given, you are supposed to take the general point as P of R bar. And this is the vector. These are the vectors. B bar and C bar are perpendicular to the plane. If I take this as a plane, this plane contains one vector AP bar. This is B bar, this is C bar are perpendicular to the plane. That plane may contain one vectors or two vectors, or let it be any number of vectors. It is perpendicular to each and every vector. Now what I do is, when these two vectors B bar and C bar are perpendicular to this plane, means they are perpendicular to what? AP. You take a cross product of these two vectors. This is nothing but B bar cross C bar. This B cross C in turn, it's a rough figure, it is perpendicular to what? These two vectors. Again, B bar and C bar are perpendicular to this plane, means they are also perpendicular to what? AP bar. This is a line passing through the point A of A bar. This plane contains the what? Line. When these two are perpendicular to the plane, that plane contains a line. Certainly these two vectors are perpendicular to that line. If you take the what? Cross product of them, you get what? B bar cross C bar. When you get B bar cross C bar, this B cross C is perpendicular to B bar and C bar. Certainly it is parallel to what? AP bar. Let us see. Now the proof of this one is very simple. Let OA bar is equal to A bar, OP bar is equal to R bar, be the position vectors of 2 points, capital A comma P. B bar and C bar be two vectors perpendicular to the line, okay, perpendicular to the line, then by definition B cross C is the vector perpendicular to the vectors B bar comma C bar, and also it is parallel to the line AP bar, which implies one vector can be expressed as scalar multiple of another vector. When any two vectors are said to be parallel or collinear, one vector can be expressed as scalar multiple of another vector. So therefore, what is AP bar? OP minus OA is equal to S into B bar cross C bar. So therefore, this is nothing but R bar minus A bar S into B bar cross C bar. So therefore, I can write R bar is equal to A bar plus S into B bar cross C bar. This is nothing but the vector equation of a straight line passing through the point A bar and perpendicular to the two vectors B bar and C bar. Okay, let us recall this concept by taking one example. Let us see. Yes, the vector equation of a line passing through the point A of 1, 3, 5 and perpendicular to the vectors B bar is equal to I minus j plus k, C bar is equal to 2i plus phi j minus k. We are supposed to find out. We know it already. The vector equation of line is R bar is equal to A bar plus S into B bar cross C bar. But let us find out B bar cross C bar first. I, j, k. 1 minus 1, 1, 2, 5 minus 1. Come on, expand it. I into, that is minus 1. Okay, minus 1 into minus 1 plus 1. Minus 5, j into 1 into minus 1 minus 2 plus k into 5 plus 2. This is nothing but minus 4i plus 3j plus 7k, right? This is nothing but what? B bar cross C bar. So therefore, now what is given? OA bar is equal to A bar is equal to 1, 3, 5. So therefore, vector equation of line is R bar is equal to A bar plus S into B bar cross C bar. S into B bar cross C bar. Come on, substitute. This is nothing but I plus 3j plus 5k plus S into B bar cross C bar. You can take minus 4i plus 3j plus 7k. This represents what? The vector equation of a straight line passing through the point A of A bar and perpendicular to the vectors B bar and C bar. Now let us start. Let us recall the concept of what? Vector product of vectors for finding the point of intersection of straight lines. Let us see what is that. The point of intersection of two lines R bar cross B bar is equal to A bar cross B bar. Next, R bar cross A bar is equal to B bar cross A bar. Okay, B bar cross A bar is dash. Now let us find out what is the point of intersection of these two lines. What is given? R bar cross B bar is equal to A bar cross B bar is one line. Another one is R bar cross A bar is equal to B bar cross A bar. Let us see. How do you find out? R bar cross B bar minus A bar cross B bar is equal to 0. I can write R bar minus A bar cross B bar is equal to 0. Whenever the cross product of any two vectors is equal to 0, either they are collinear or parallel. So therefore, one vector can be, which implies R bar minus A bar comma B bar are either collinear or parallel vectors. There exists scalar S, which implies one vector can be expressed as scalar multiple of another vector. So therefore, this represents R bar is equal to A bar plus SB bar. This represents a straight line passing through the point A bar and parallel to the vector what? B bar. Next, in the same fashion, R bar cross A bar minus B bar cross A bar is equal to 0. R bar minus B bar cross A bar is equal to 0. Now here, whenever the cross product of any two vectors is equal to 0, they are either collinear or parallel vectors. Then there exists scalar T such that don't use the same scalar as we discussed earlier. While you are finding the point of intersection of two lines or two planes or a plane and a line, you are not supposed to use the same scalar. Therefore, I can write R bar minus A bar is equal to S into T into A bar. You can take S already used. So therefore, T into A bar, where T belongs to R. T belongs to R. So therefore, one vector can be expressed as scalar multiple of another vector. So therefore, R bar is equal to B bar plus TA bar. This is also a line passing to the point B bar and parallel to the what vector? A bar. So now you take this as a 1. Now this is 2. Let us assume that these two lines intersect at P of R bar. Why it's a R bar? It's R bar. So therefore, let P of R bar be the point of intersection of, be the point of intersection of 1 and 2. So therefore, now A bar plus SB bar is equal to B bar plus TA bar. Yes, by equating the like terms, I have T is equal to 1, S is equal to 1. You can take either T you substitute or S you substitute as you please. Yes, if I put S equal to 1, R bar is equal to A bar plus B bar. If I put T is equal to 1, R bar is equal to A bar plus B bar. So therefore, position vector of point of intersection of lines R bar is equal to A bar plus B bar. R bar is equal to A bar plus B bar. Yes, we have discussed about how to find out the point of position vector of point of intersection of two lines when you are given with the data in terms of cross product. That is a point of intersection of two lines R bar cross B bar is equal to A bar cross B bar, R bar cross A bar is equal to B bar cross A bar. So what is that is? These are the what come on after getting this is 1 and 2. These are the lines. Let P of R bar be the position vector of a point of intersection. Transfer to LHS. Take out the common factor. When the cross product of any two vectors either here or here is equal to 0 means they must be either collinear or parallel. One vector can be expressed as scalar multiple of another vectors. In both the cases, here S, here T. I could get two vector equation of straight lines. Let us assume that P of R bar is the point of intersection. So therefore, we have got the position vector of point of intersection as A bar plus B bar. Now, by giving this one is, he can, whenever he gives two vectors, he may ask like this. Okay, one example. Find the point of intersection of two lines when A bar is equal to I plus 2j plus 3k, and B bar is equal to minus 4i minus 7j plus 6a equals. Then, okay, now the point of intersection of two lines, R bar cross B bar is equal to A bar cross B bar, R bar cross A bar is equal to B bar cross A bar. When A bar is given, B bar is given. Yes, as we have discussed just now, what is the point of intersection of these two lines? Just I can write point of intersection of two lines is R bar is equal to A bar plus B bar. R bar is equal to A bar plus B bar. Just add the two vectors. You get R bar is equal to S common I minus 4i minus 3i, 2j minus 7j minus 5j, 3k plus 6k, it's a 9k. So therefore, the position vector of point of intersection of two lines, when these two data are given with what? A bar is equal to something, B bar is equal to something, is given to be what? A bar plus B bar. Add the two vectors. That gives the position vector of a point of intersection of two lines. Yes, students, let us discuss about when three lines are given in a plane and another line which is equally inclined with the three lines. Three lines are nothing but three vectors. When a plane contains three vectors, say for example A bar, B bar, C bar, you take another vector R bar which is equally inclined with the what? Three vectors A bar, B bar, C bar. Then whatever the vector which is equally inclined with the three lines, three vectors, it will be always a what? Normal to the plane in which that contains what? A bar, B bar, C bar. What's the statement? Let us see. Let the lines L1, L2, L3, L1, L2, L3 lie in a plane pi. Okay, these are the three lines. If a line L is equally inclined with these lines, then L is a normal to the what? Plane pi. So therefore, now what I do is, I start, if I go to the what figure, convincing is difficult, satisfaction level will be very low. So therefore, better discuss with the what? Theoretical approach. Let A bar, let the lines L1, L2, L3 are represented by the unit vectors. Unit vectors A bar, B bar, C bar, and R bar be the what? Unit vector is along the line L. What is given? The line L is equally inclined. Given the line L is equally inclined to the lines L1, L2, L3, which implies angle between R bar and A bar is equal to angle between R bar and B bar, angle between R bar and C bar is equal. Means dot product cos theta is equal to R bar dot A bar by modulus of R bar into modulus of A bar. Similarly, R bar dot B bar by modulus of R bar into modulus of B bar. Similarly, cos theta is equal to r bar dot c bar by modulus of r bar into modulus of c bar. Since we have taken a bar, b bar, c bar and r bar as unit vectors, their magnitudes is equal to what? 1. Directly you can write cos theta is equal to r dot a. Now cos theta is equal to r dot b. Cos theta is equal to what? R dot c. Nevertheless, I can write r dot a is equal to r dot b is equal to r dot c. Now you consider, I can write this one as from this r dot a is equal to r dot b. Okay, similarly r dot c, r dot a is equal to r dot c. If you want, you can consider r dot b also. It makes no difference. Therefore, r bar dot a bar minus r bar dot b bar is equal to 0. Is equal to 0. Next, r bar dot a bar minus r bar dot c bar is equal to 0, which implies r bar dot of a bar minus b bar is equal to 0, r bar dot of a bar minus c bar is equal to 0, which implies whenever the dot product of any two vectors is equal to 0 means they are either perpendicular or each must be equal to 0. So, must be about 0 vectors. It cannot be. They must be perpendicular, which implies r bar is perpendicular to both a bar minus b bar and a bar minus c bar. Now, which implies r bar is perpendicular to both a bar minus b bar and a bar minus c bar. You can very well observe, if I take a what plane, or else if I take a bar, if I take a b bar according to cross product, this is nothing but a cross b is the vector which is perpendicular to both a bar and b bar. So, when r bar is perpendicular to both a bar minus b bar and a bar minus c bar means, which implies r bar is parallel to a bar minus b bar cross a bar minus c bar. What is this? A bar minus b bar cross a bar minus c bar is a vector perpendicular to both a bar minus b bar and a bar minus c bar. This is nothing but what? R bar, when r bar is parallel to this. So therefore, when this is perpendicular to both, certainly r bar must be this. So therefore, which implies r bar is parallel to a cross a. A cross a becomes 0. I can write a cross a. Next, minus a cross c. Next, plus, I can write here, minus b cross a plus b cross c. So therefore, r bar is parallel to, yes, now this becomes 0. You change it as c cross a, you change it as a cross b. Therefore, a cross b plus b cross c plus c cross a, right? So therefore, now this is nothing but a normal to the plane containing a bar, b bar, c bar. Followed? This is also a normal to the plane containing a bar, b bar, c bar. Therefore, r bar is parallel to what? The normal. Therefore, r bar is also normal to the what? Plane of what? A bar, b bar, c bar. Since a bar minus b bar cross a bar minus c bar is a normal to the plane of a bar comma b bar comma c bar, which implies a cross b, b cross c, c cross a is a normal to the plane of a bar comma b bar comma c bar. This is nothing but r bar, which implies r bar is a normal, means perpendicular, normal to the plane of a bar comma b bar comma c bar. Hence, whenever a line, that's what L is a normal to the plane pi. Once again, let the lines L1, L2, L3 lie in a plane pi. If a line L is equally inclined with these lines, then L is a normal to the plane pi. So now in this concept, you come across dot product as well as cross product in defining L is what? Normal. So therefore, let the lines L1, L2, L3 are represented by the unit vectors A bar, B bar, C bar, or else the unit vectors A bar, B bar, C bar are along the lines L1, L2, L3. You can also take in that way. So therefore, R bar with the unit vector is along the line L bar, L. So therefore, given the line L is equally inclined to the lines L1, L2, L3. So therefore, equally inclined means what? Cos theta. Cos theta is equal to what? R bar dot A bar. Cos theta is equal to R bar dot B bar. Cos theta is equal to R bar dot C bar. Since modulus of R bar, modulus of A bar, modulus of B bar, modulus of C bar is equal to 1, directly you can write cos theta. No need to write cos theta also. It implies R dot A is equal to R dot B is equal to R dot C. Select these two, select these two. Take the what? Common dot product of R bar. Dot product of R bar is a common factor. It means that R bar is perpendicular to both A bar minus B bar and A bar minus C bar, and R bar is what? Parallel to what? A bar minus B bar cross A bar minus C bar. Why? This is a vector perpendicular to these two. Therefore, R bar is parallel to this. So when R bar is parallel to this, now you say take the what? Cross product of this A cross A, B cross A like this. So therefore, now this becomes now A cross A minus A cross C minus B cross A, B cross C. Change the direction. Instead of A cross A, C cross A, instead of minus B cross A cross B. So therefore, whenever interchange the what? Cross product sign changes. So therefore, R bar is parallel to A cross B plus B cross C plus C cross A. A bar minus B bar cross A bar minus C bar is a normal to the plane of A bar, B bar, C bar. A cross B plus B cross C plus C cross A is a normal to the plane of A bar, B bar, C bar. So therefore, R bar is a normal to the plane of what? A bar, B bar, C bar. Let us see. As we have discussed just now, find the point of intersection of the two lines R bar cross B bar is equal to A bar cross B bar. Meanwhile, R bar cross A bar is equal to B bar cross A bar. We have found out the point of intersection as R bar is equal to A bar plus B bar. The same concept little extended to what? Locus. So therefore, whenever, wherever you come across the locus of a P with respect to the cross product means we are supposed to get its locus as what? Straight line. Let us see. Now, the proof of this one is, let OA bar is equal to A bar, OP bar is equal to what? R bar, be the position vector of capital A comma P respectively. Why? P is any point in a plane. So P of A R bar is any point such that, and given, what is given? R bar cross B bar is equal to A bar cross B bar is given. So which implies I can write R bar cross B bar minus A bar cross B bar is equal to 0, which implies R bar minus A bar cross B bar is equal to 0. Whenever the cross product of any two vectors is equal to 0 means they either collinear or what? Parallel. So therefore, I can write R bar minus A bar is equal to SB bar, which implies R bar is equal to A bar plus SB bar. So therefore, where S belongs to R, this represents a straight line passing through the point A bar and parallel to the vector what? B bar. Hereafter, remember, when the two cross products are equal under the presence of what? General point R bar, its locus is always a what? Straight line. Its locus is a straight line. Students, let us discuss about the application of the cross product under the definition of non-collinear vectors, linearly independent vectors. We know that The non-collinear vectors are nothing but linearly independent vectors. Collinear vectors are what? Linearly dependent. So, by using the definition of cross product, how to identify the nature of the triangles with the sides under the linear combinations. Let us recall the what concept of what linearly dependent, linearly independent, collinear and non-collinear vectors under the definition of cross product in deciding nature of the triangles. Let us see. So, if P bar comma Q bar are two non-collinear non-zero vectors, and he has given the what linear combination. What is linear combination? Just like XA bar plus YB bar plus ZC bar. So therefore, now what he has given? B minus C into P bar cross Q bar, C minus A into P bar, A minus B into Q bar. He has given some linear combination where A, B, C are the lengths of the sides of a triangle. But when lengths of the sides of a triangle are denoted with what? A, B, C. This is A, this is what? B, it's a C, A, B, C. Right? A, B, C. So therefore, now what I write is, with the linear combination given P bar comma Q bar are non-collinear vectors, which implies when they are non-collinear, then the three vectors are linearly independent. What they are? Linearly independent. We come across two types of definitions. One is a linear combination method, other is what? Det method, determinant method. For linearly what? Independent, determinant is not equal to 0. For linear combination of vectors, let us recall the what definition of this. So XA bar plus YB bar plus ZC bar is equal to 0. When three vectors A bar, B bar, C bar are said to be what? Linearly dependent, at least one scalar must be different from 0. How many vectors are there? Three vectors. How many scalars are there corresponding to it? Three scalars, X, Y, Z. So therefore, at least one scalar must be different from 0. All may be different from 0. Then we call it as what? A bar, B bar, C bar as what? Linearly dependent. For what? Independent, all scalars must be equal to what? 0. Means, if A bar, B bar, C bar to be what? Linearly independent, all the scalars must be equal to 0. Yes, when P bar comma Q bar are non-collinear vectors, which implies P bar comma Q bar, P bar cross Q bar are what? Linearly independent. This is X, this is Y, this is what? Z, which implies B minus C is equal to 0, C minus A is equal to 0, A minus B is equal to 0. It is quite obvious A is equal to B is equal to C. Means since A, B, C are lengths of the sides, when the lengths of the sides are equal, they represent a what? Equilateral triangle, which implies small a comma B comma C represent sides of a equilateral triangle. What triangle? Equilateral triangle. Right. Once again, deciding the what? The nature of the triangle under the linear combination by using the cross product. Little higher standards, as we have verified earlier as what? Equilateral triangle. Under that you come across right angled what? Acute angle triangle. That is what? Isosceles obtuse angle triangle, only right angle triangle, only equilateral triangle. Let us see. So now what he has given, if P bar and Q bar are non-zero, non-parallel vectors such that A minus B into P bar, 5B minus 3C into Q bar, 10A minus 6C into what? P bar cross Q bar is equal to 0 bar. When LHS is a vector, RHS must be equal to what? Vector. And where ABC are the sides BC, CA, AB of a triangle ABC, then the triangle is dash isosceles A right angle triangle, obtuse angled isosceles triangle, and D is what? Equilateral triangle. Equilateral triangle. Let us see. Now, the proof of this one is very simple. Given P bar comma Q bar are non-parallel vectors. Non-parallel vectors. So therefore, which implies P bar, Q bar, P bar cross Q bar are linearly independent vectors, which implies A minus B is equal to 0. It's a linear combination x, y, z. All scalars must be equal to 0. So therefore, 5b minus 3c is equal to 0. 10a minus 6c is equal to 0. So therefore, a is equal to b, 5b is equal to what? 3c, and 10a is equal to what? 6c, right? Now, if you solve these two, you get a is to b is to c is equal to what? 3 is to 3 is to 5. You solve these two. Certainly you are going to it. So you can very well observe A is equal to B. A is equal to B means length of the two sides are what? Equal. It is quite obvious it must be an isosceles triangle. Let us verify it is an isosceles triangle, and meanwhile verify A square plus B square. What is A square plus B square? 9 plus 9 is equal to 18. So therefore A square plus B square is less than what? Come on, C square. That C square is equal to what? 25. So therefore it's an obtuse angle triangle. Hence I can write the triangle ABC. Triangle ABC is an obtuse angled isosceles triangle. Okay, triangle ABC is what? Obtuse angled isosceles triangle. Why obtuse angled? Sum of the squares of the two sides is less than the what? Third side. Hence we can call it as what? Obtuse angle triangle. And the length of the two sides are what? Equal. Hence we can say that triangle ABC is what? Isosceles. On the whole, we can say that the C option, obtuse angled isosceles triangle, is the relevant answer. Thank you.